we'd like to hear from you. So if you, well, I guess I need my presenters to come up. We can't let the name tags go to waste, gentlemen. So to our audience members, you'll see there are microphones in the aisles for your convenience. I want to thank you all, first of all, for your attention and your engagement tonight. And step up, don't be shy. We've got about, I don't know, we'll see, 20 minutes or so? 10 minutes? Okay. Well, we'll see. Up to you guys.
We talk too much.
Feel free to introduce yourselves, direct a question directly to Douglas, David, or Jeff, or if you'd like all three of them to answer your question, that is also welcome. So I'll turn it over to you.
Do we need a mic?
In the aisles. Of course, you're right in the middle, sir.
Oh, we can hear you, yeah. We'll repeat the question.
So I'm David Katz from the Ontario Smart Grid effort, and so I'm very interested in the last portion about resiliency for the games as it relates to the generator. So what is that? Is that a combined heat and power plant that's part of the building?
No, that's just
Just a standby?
it's a standby emergency generator.
Why weren't these games made with some innovative energy other than PV on the roof? Like combined heat and power or any of those? Any thoughts on that?
Yeah, I mean, I think that was something that some of the proponents proposed as innovations. I think it was really a budget and cost thing. The generator really is a viable way of supporting the games.
That's it, it's just an emergency generator.
Yeah.
Hi, my name is Bikramjit. I have a question for Jeff. Jeff, you was mentioning about the geothermal as well as the solar panels above, right?
Yeah.
Is that Aqua Center is been given full utilization of electricity through these two mechanisms, or you still hop onto the external lines?
Yes, definitely. We're still open to the external lines.
So
solar panels probably handle 15 to 20% of the sort of steady state power.
Mhm.
And in terms of the geothermal, it probably handles 90% of the heating and about 40% of the cooling. So it's really only the peaks that are supported by conventional means. If that gives you.
So after this main Pan Am event, during the regular use by community or during the regular use for University of Toronto, is it sufficient to support its own?
No, it's not self-sufficient, no, from those two means, but it definitely does help. I mean, it was something that we looked at, the cost versus the long-term operation. So a modest size system, especially in the geothermal, something that could run sort of at a steady state, was more economically attractive than something that would sort of only run at part capacity for a longer time.
Okay. One question for Doug as well. With respect to your Milton velodrome, maybe I'm wrong, but I didn't see that there is any planning of the geothermal or the solar panels in that facility. Is that the reason, or is it like I missed that point?
I think it's more a question for you.
Yeah, I mean, just from the building perspective, as a proponent, we just work within the terms of the project agreement. And as far as I'm aware, on Milton, there was no requirement for either geothermal or for a photocell application on that particular job.
Okay. So was a specific reason, like because we seen here, we are talking about LEED and energy efficient, and these are the two pretty good elements for the energy efficient thing.
Yeah, I think we, through the design, we had sufficient for the LEED silver. I would suspect that the the PV system and geothermal was probably more cost-driven as well. There was no requirement for the LEED certification, so there was no need to spend the additional funds. But for us as a proponent, that wasn't part of the requirements of the RFP process.
Okay. Thank you.
My name is Janusz Moore, I don't know whether you guys can hear me. So my question is for John. Is the mechanics of this 3D laser scanning, could you explain to us how it happened?
Okay.
Okay, so the 3D laser scanning you mentioned,
Yes.
so how did it happen? I mean,
Well, I think they use a LiDAR system. I mean, actually, one of our BIMSers is here tonight. He might be able to explain a little bit better. But it's a LiDAR system with millions of points taken through a spinning transmitter. So it's basically sending off laser points, millions of points throughout the facility. So you have to set up in different locations so you can cover all aspects of the facility. If you just set up in the one location, you'll just get that one perimeter.
I see a lot of, my name is John Hanson. I see a lot of wood used in the construction of this facility. Did you, either David or Jeff, did you take any special precautions when you ordered the wood, had it seasoned, and then kept it on site so that you didn't have any movement, or have you experienced some movement?
Well, for the velodrome, I probably skipped over it a bit, but the wood did have to be seasoned. It was harvested, I think, in late 2012 and wasn't delivered to the job until the middle of 2014. So through that time, I think there was probably close to a 12-month seasoning period just to get the wood to a stable condition. Then it was pre-cut, pre-assembled, and packaged in moisture-proof containers, shipped to the job site, and actually sat on the job site for about 4 weeks in the containers, actually maybe a little longer. But it was moisture barrier protected and environmental conditions. So when the wood arrived in the facility itself, it was already preconditioned. There was no issues with movement of the wood. But it's important to maintain the facility, as I said, at the prescribed humidity and temperature levels, so that you do get some movement within the wood once it's actually nailed into position, and that can be accommodated to a certain extent. But you want to really minimize the change in humidity, certainly.
That actually creates schedule issues for a lot of these projects. That like at Markham, they wanted to put down the wood before the building was sealed, and it's with all due respect, it's standard contractor stuff. And
Well, why can't you do that?
yeah. What? And we had to say no. It can't. You have to stop until you get something in place so that there's some stability to the environment before the wood goes down. Because of course it's a live material, and it's got to be, the range of humidity has to be quite fixed before you can put it down.
And you're comfortable with that, are you, Jeff? Maintaining it over the long term?
Well, yeah. I mean, the only area that we have wood is really on the basketball court. And that was installed when the building was enclosed, so that was to a lesser degree, I guess. Other than that, and millwork.
Good, thank you.
I was wondering if you could go back 4 years and teach yourself something that you wish you knew then that you know now, what would it be for the design or engineering?
I would have bid higher. Is that?
If you're asking the contractor, Doug already gave me the answer. Yeah, we would have bid higher. Thank you, Doug. But in seriousness, I think we would certainly perhaps have taken a different approach on the P3. The P3 model for us is relatively new. It's been used in Ontario probably for 8-9 years now. But it is a difficult model. I mean, Doug mentioned the number of people involved, a number of different parties involved, and as a contractor, I'm not convinced that that's the best approach necessarily. It certainly gives cost certainty, but it also it's created a new industry for lawyers as well, a large industry. So so I'm not sure that's a learning opportunity, but certainly that would have helped. And Yeah, a bit higher.
I
Sorry.
just have a, okay, sorry.
Can we go to microphone first?
Okay, just have a question. So for the Veradome and Velodome and Aquatic Center, how much did it cost per square feet, like at the end, like for the construction, and how long did it take? Was it 1 year or 2 year project?
Well, I can talk for the velodrome. To be perfectly honest, I've never thought of it in terms of square feet because it's such a unique building, but the actual cost is about $40 million. It was a bargain at the price, but it was $40 million. And we started in April of 2013. It was, the first event was early January 2015. So about 18 months.
Yeah, I mean, it's always hard to do square footage costs, but at the end of the day, you know, the aquatic center was in the $450 a square foot range. These are very, very technical buildings, like the pool equipment alone is, you know, something else, and the structures are wide span and so on. And the construction period was actually quite fast. It was about 2 years, and a lot of that was designed into the process. And I think that, you know, the question before, what would I have done differently, is the experience coming out of Markham was, I think really we would have designed everything, even in the indicative schemes, much more towards more systematization. You know, like the precast panels at Markham were fantastic because they just went up and very, very quickly. And it was interesting where the things slowed down were the less modularized components. And so anyhow, the construction period was quite fast. It was all steel and with very simple concrete core where it made sense from a fireproofing, and where you had high loads through the central spine, and then everything else was very fast erection components.
Just a general question. What's the state of the art with swimming pools and the water and the atmosphere in the swimming pools?
I sort of alluded to it, but the state of the art is it's become quite fixed since Beijing, actually. The kind of a depth of the pool is quite fixed, and that's actually one of the legacy problems, is that, for instance, you want it to be all one shape. So both of the pools at PAC and so on have these quite extraordinary movable floors to turn them into legacy mode. But they have to be 26 degrees within plus or minus 1 degree. There's a clarity issue, so the just cleaning the pool becomes a very, very big issue in terms of it being a performance pool. That if it's foggy at all, the swimmers can't judge when they're at the head wall, and that's, of course, you know, turning is the whole thing. And so that aspect's quite important. And then the other environmental concern is just simply chlorine. You know, in older pools, it's toxic as hell. Like, swimmers actually develop some very bad breathing issues because of the environment they're in, you know, often 16 hours a day. So there's been a kind of discussion about moving to salt pools, in fact, to improve that characteristic. But of course, they're a nightmare to maintain. But salt pools also potentially create more buoyancy, so they're hoping for faster times out of that. So, and and also that the environment has to be within 2 degrees above the 26 degrees. So they're kind of warmer environments than what you would normally have to again, so that the swimmers stay warm and so on.
Yeah, we're also using UV in combination with the chlorine, so it's sort of reducing some of that burden, but
Yeah.
still definitely.
So are you chlorine being used, or is it?
It is,
Oh,
yeah,
yeah.
it's just in very small amounts. So there's UV sort of pre-treating the water before the chlorine is.
Like the Olympium, just a terrible environment. Like, it's sort of notorious for swimmers. The Etobicoke Olympian, before we fixed it, but it was noted for its horrible effect on swimmers.
So we have to rewrite the record books then if we go to a saltwater pool?
No, but they just get rewritten. All like those Olympic records that were broken wearing those bodysuits still stands, even though they're banned.
And then there's a certain decade of swimming, the East German swim
Yeah.
team. Yeah,
Yeah.
few Canadians kept off the podium for that one.
Ravi Gupta, the question is for Douglas. Architecture precedes engineering. So, and you mentioned something about infrastructure material
Yes.
as one of the controlling units in the work that you did at that stage.
Yes.
At the end of the game, it's the bottom line that makes it a successful event or not. Was there any wow factor in all the work that you did, or there was a major consideration of cost effectiveness? I heard you say that there's anticipated $8 billion overrun or something like that.
No, that's not for the game, sorry. That is just I have to be clear about that. The Auditor General report stated that, in their opinion, since Infrastructure Ontario started this program, which was, what, I guess 10 years ago now, it's been running, they feel that there's been an $8 billion delta. But that's over that. That includes all the hospitals, prisons, et cetera, that they've built.
Was there an economic equation in the work?
Oh yeah, no. So the Pan Am Games had a very fixed notion of what the budget should be. Each site, I mean, the budget of course shifted and changed as we developed the baseline buildings, the indicative schemes or illustrative schemes, but they were costed all the way along, and it was there was no kind of desire to see, say, something that looked like the Velodrome in London with this kind of extraordinary catenary structure and so on. But I mean, that being said, part of the idea of Infrastructure Ontario is of course all about the bottom line and schedule. But I think the idea of most architects who work within it is to try and find a wow factor within a kind of a reduced cost. And for instance, the system for Markham, we're quite pleased with the wood structure in the ceiling, which we could have just as easily gone to a standard steel, kind of open web steel joist type system, or just putting some of the kind of metal fins on the outside wall, which is a bit of frippery, I guess, but it adds a bit of kind of community value to the process. So I mean, Infrastructure Ontario is undoubtedly all about the bottom line, but it's still, we try as architects and builders and so on to give some amenity and grace to these facilities. I think some of them succeeded quite well myself.
Gentleman in the middle.
We had a pretty bad ice storm there a year ago. Did that change your design for your routes? A pretty that massive snow loads, obviously, you take into account. Did that change your design at all as a result of that?
That's a really interesting question. No, it didn't. We design to those events now with modern buildings. Our biggest problem with ice storms now is actually our buildings are too good. It's quite an interesting thing. Like, for instance, the TD Centre has never had ice problems. We just reclad the TD Centre. It used to be a single glazed building, if you can imagine, that huge beast, the first three towers. Now we've double glazed them. The ice sticks to it. Never used to, just melted off. So now you've got shedding ice problems, and this is a problem with all high performance buildings, is how do you deal with the fact they're actually performing the way they're supposed to, and they're not leaking air, so that you have this same problem you have with cars and so on now that we didn't used to. So this is an ongoing process of the buildings are designed to accommodate it. It's a problem of what you do with it when it falls off and kills people on the bottom. So that's actually just, we're not there yet with that.
What about the snow load on the large roofs?
Well, they're designed now for the 100-year event. So we have truly failed if those things fail now. I mean failed at a liability level, as in you didn't do it properly, but they're designed for that.
Nobody likes our microphones, but
Yeah.
you all seem to speak loud. It's quite all right. You can stay there.
My question is for David. Actually, first of all, I want to say thanks for the interesting 3D.
That was cool.
And my question is, how many percent of this
Can you give me half an hour?
And my second question is, as I see, two sides of the project have a huge and massive value of backfilling the soil. And I want to know, actually what was the reason that your design for the deep and of excavation wasn't balanced with this much of backfilling with soil?
Yeah, well, I'll start perhaps with the first one. You know, the $40 million, and I'd have to estimate this a little bit, it's probably about 10% is design cost. Materials, equipment, it's probably quite high. I'm thinking 30 to 40%. The ventilation equipment, as an example, was a very expensive item. The structural steel, concrete, the backfilling you just mentioned, but the M&E systems themselves were very expensive. The labor component on a job like that, maybe 20% of the cost. So labor is not, you know, maybe the numbers don't quite add up here. I've got to add the 10 to the 30, 40, 20, but the labor typically isn't the largest cost that you have in a facility like that. Certainly materials and equipment would be a very big part of it. As far as the excavation goes, I'm not quite sure I was following the question. You know, we're on basically it's a fairly low-lying area. The most economical foundation solution was simply to get down to reasonably competent material and then bring it back up with unshrinkable fill as opposed to going through a piling, caisson type of arrangement. It was also more a time-saving factor as well. And then we did have to import, I think I might have mentioned, close to 50,000 cubic meters of material to bring it up to the required grading, particularly on the east side. But that was a requirement of the design of the facility, and particularly allowing access at the level 3 for viewing public, so at a much higher elevation than the general access to the facility. So that was more of a grading requirement for the building. And so we opted not to use piling or caisson type foundations because, one, this is a more economic approach, and it was probably a quicker approach as well. Does that answer?
Is an hour answer for this question. I might as well start. So in the beginning of this process, BIM is, frankly, I hate it. And I'm a very early adopter of computers and 3D modeling. I love 3D modeling. That being said, I think one of the powers of architecture and design was when we took the 3D world and projected it into 2 dimensions. It allowed us to look at things in an abstract way. And the problem with BIM, I mean, it's interesting that Autodesk didn't make any inroads with architects, or very few inroads, until they started selling it to contractors and developers who forced it down our throats. And I mean, the irony is, of course, it hasn't really paid off the way it was supposed to. That being said, it's here to stay. It's not going anywhere, and we're all just figuring out what to do with it. It's such early days, but you know, you cannot create a perfect environment. Like, for instance, if you've ever worked with sprinkler guys, like, they don't give a good goddamn what you draw. And so you draw a perfect fall, the sprinkler's going this way, and all the ducts are fitting underneath it, and then the guy comes and he puts it sloping this way. So your whole mechanical system, you gotta throw out. So there's these kind of issues, but some of the interesting things that are happening in IO, in some ways, it's all kind of coming together in some weird mix. For instance, I'd be interested to know how you're handling your shop drawing. So what's a shop drawing look like in a 3D environment? So one of the interesting concepts is that we build our model, and then we slowly over time swap out pieces. So here I've got the structural model. I have a structural model. Your structural guy comes and gives us a structural model. We swap it in, and see if it works. And then the mechanical, you know, here's my mechanical drawing. Now you get the BIM mechanical drawing as a shop drawing from the supplier who's going to use it to manufacture his product, and then you swap that into the model and see if it fits. So the kind of relationship between this sort of living model that's slowly moving along, and then that idea of using LiDAR and laser to actually do a kind of as-built as it's being built is a kind of extraordinary thing, because then now you're swapping out the shop drawing and swapping in the actual thing to see if it's all still meshing, you know. And so there's something very interesting in that process. But as a kind of device to draw, it's slowing architects down terribly on idiosyncratic buildings. It's great for big box, you know, Walmarts. For anything else, it's a pain, and it's costing us fortunes.
So from the contractor's perspective, though, we love it. And, you know, I sympathize with Douglas too. I think, you know, I'm an engineer by training, and when I came through university, we didn't have computers. In fact, I think I got the first HP 19 that was available, so I used to use a slide rule. So I was taught basically to sketch it up first, and then if you can make sense of that structure, then you can start modeling it perhaps, but you better understand your structure first. And I think probably the concept is similar for architecture. You know, you're creating something as opposed to drawing something. But when it gets to the point where now we actually have drawings in 3D, or we have models, it's a very important tool for a contractor, because you mentioned shop drawings and you asked about ventilation, ducting and stuff like that, and the answer is yes. Most of the shop drawings now for sophisticated subcontractors and contractors are produced using models, or using at least a 3D format. Structural steel on the velodrome, for example, was the drawings were created through the model. And you know, really what it does is it identifies issues early. It takes out a lot of human error. I'm not saying there's still not problems, but it certainly does make that process of generating shop drawings and then perhaps feeding them back to the design community in that same format. You know, it does take a lot of time and effort away from what we do as contractors. Ultimately, on the Revit model, for example, we're just finishing building our own new head office, which for some reason takes longer than what we thought it would take. But that's, as my boss says, it's a bit like the shoemaker trying to make his own shoes. But in that, we've really taken a fairly rigorous approach to the use of a Revit model, and we're trying to embed into that model the specifications and product data and operating information that we need to actually function the facility as an end user as well. So I don't know, Jeff might talk a little bit more about that, but certainly long term you would like to see more of a seamless approach between the design through the construction and then into the actual facility operation. You know, we've used it in some of the process plants that we build for water and wastewater, and the operators love seeing the model, because they can see how some of the piping conflicts and, you know, some very basic stuff, but certainly it's a very powerful tool for a contractor.
Yeah, to answer your question, we're starting to use it, so we have a few pilot buildings that are using it, and we're beginning to get back. I mean, typically at the end of a project, there's a library of binders that house all of your material that you've just purchased, and you have to maintain, and this is hopefully going to make that process easier. So it's something that we've requested in the newer buildings, to both try and make things more accessible and to manage the long-term maintenance and easier. So
I mean, it's all going to get better when the next generation of kids who are all raised on Minecraft, like, you know, everything's 3D, and, you know.
At the microphone first, please. Oh, no. Yeah.
Good night. Thank you for the presentation. It was great to see a nice project. For the architectural design, I would like to have some comment regarding how come we didn't consider to design a green roof on the structure, and also what was taken in account if we have any fire rating on the decking of the velodrome. And for the structural portion, Did we spend a lot of money in the winter coast? Did we protect the footing during the cold weather? Or did we tackle all those things before it happens? And for the financial portion, since we are hosting this game, are we recovering the investment as a taxpayer? We are worried that, like in Markham Arena, they say like Royer Center, they cannot anymore longer sustain the cost of the maintenance. So do we consider any items regarding to tackle the cost of the maintenance during the long time life of the building? Thank you so much.
Yes.
I'm not sure that I caught the first question, but the answer to the winter protection is that, yeah, we went through a pretty difficult winter in 2013, 2014. And it's an expensive construction when you have to enclose a facility so that you are bound to a schedule. You have to make sure that your facility is still constructed in accordance with the requirements of the specifications, which means temperature and weather control. And in respect to the fireproofing, yeah, I think the OBC governs, but anywhere where you have I think a suspended slab in a facility like that, which is not concrete, so deck on steel, everything like that is fireproof from the underside, yes, and fully sprinkled.
I think your first question was about green roofs, and I just a quick commentary on green roofs is that from a sustainability perspective, they're a kind of interesting phenomena to me. I think one of the things about sustainability that gets confused is it has to be sustainable. And one of the problems of like green roofs now are being forced down the throats of everybody in Toronto is that at least 50% of people who have to put them in don't want to put them in. So they're not going to maintain them. So they're therefore not sustainable. You're better off doing a white roof when somebody doesn't want to maintain the roof. So there is that kind of issue. The second thing is it sustainable to add a pile of structure to support a bunch of dirt that has to maintain that green roof in a situation where, you know, we are trying to keep the budget down? And as you said at the latter part of your conversation, what about maintenance over time for these things? I think that's what you're asking. And, you know, it is, you know, you're adding costs to the structure, you're adding a kind of maintenance issue when from a literal performance perspective, a white roof actually does probably a better job generally. So there's kind of, for me, there's issues in there about how we treat sustainability, and that I'm just going to shift to the maintenance perspective. If you've done a really good sustainable building, in my opinion, you're using LED lighting, you're using mechanical systems that you know are going to be maintained properly and are going to reduce energy loads by, say, 30%. For instance, geothermal now is a mature technology that a building maintenance guy knows how to use. Whereas, say, for instance, advanced photovoltaics and so on, they don't really have much payback. People don't keep them clean. They actually, I personally hate them. I just think they shouldn't be used on buildings until the technology is there. Whereas solar hot water is kind of advanced technology. It's used everywhere in China. It has direct payback. You can heat your pools with it. It's really great technology and it's easy to maintain. And so to me, the kind of relationship between maintenance and sustainability are actually quite direct. And we try to do that, for instance, at the Markham Aquatic Center to make sure that the systems are usable, that we don't have the solar gain that you would typically have in those kind of structures, that their roofs are white, you know, et cetera, and it's easy to keep up.
Yeah, to the point on the green roofs, I mean, I think that part of our decision making when we went to solar panels was to alleviate some of the green roof burden that we would have in long-term maintenance, and to have the solar panels, we got some value out of it in terms of the ongoing utility bill. So that was part of our decision making for sure, that the green roof upkeep and long-term sustainability.
Okay, and our question period's winding down, so I'll ask our last question person at the microphone to ask away.
I have the question to David regarding safety. during construction, because as far as I understand, the time is very limited, constraint. You have the rush to finish the job right in time. My question is there any occurrence, incidents happen during the construction? You have to tell us so that we can learn some lesson from that. I mean, any accident, any occurrence, incidents which need to be known to us so that we can learn from that. In future, we can protect.
Yeah, no,
Thank you.
we were very fortunate that there was no significant incidents. In fact, I think the incident of medical aid was very low as well, considering the congested site and the number of people working on it, working 2 shifts in some cases as well. So, you know, what we find with safety, one of our biggest approaches is to be very proactive and to constantly reinforce it. These days, contractors more and more are having certified safety professionals on job sites, and in fact, each of the Pan Am facilities, probably not just the ones we worked on, but all of them, would have had a dedicated site safety officer on the job. And it certainly was a requirement for us, but it's probably a requirement for all of the contractors, and that person was on site through any construction activities. And the role of that person varies. It's not just enforcement, it's also education, and it's continual education, because no matter how much you preach the safety ethic, no matter how much you train people, people can still do dumb things. And so you do have to be constantly reminding people of the approach. You have to be looking at your construction sequencing so that you minimize any activities which are overlapping, where you may create dangerous conditions. So it's a very proactive approach, but certainly having the certified professionals on site on a full-time basis is a very important part of a facility such as the Velodrome, or in fact any of these fast-track facilities, because you've got a lot of potentially critical activities happening concurrently. We were fortunate, there was no significant incidents, no.
I'd like to thank you all for your questions. That concludes our question period. And I also just want to thank our panelists, our presenters tonight, Douglas, David, and Jeff, taking the time and care outside of their regular jobs on a day-to-day basis to put some, a great learning opportunity for all of us here in their presentations, and to take some time outside of their life, outside of work, which is apparent. Some of us have lives outside of work, sometimes.
Not really.
At this time, I'd like to ask Rajiv Ratan to come up and say some concluding words.
Good evening, ladies and gentlemen. On behalf of Engineering Innovation Forum, I would like to thank all speakers, Douglas, David, Jeff, together with our brilliant moderator, Signa, for putting up such a nice presentation that was not only exciting, but very informative too. Most of the people may not be knowing what velodrome is even, and today they know what it is. Okay? So this was a very informative session. I would like Douglas, David, Jeff, and Signa to please come over here and accept a small token of appreciation on behalf of Engineering Innovation Forum. Ladies and gentlemen, our gratitude goes to our sponsors and exhibitors. Without their support and participation, an event of this magnitude would have not been possible. I would like to thank members of my organizing team who have not only volunteered the time and have taken tireless work over the last several months to put this together and bring it to such a standard at which we can present it to you. Above all, I would like to thank you, the audience, who came in such a large number here, leaving your other assignments which gives us the proof of the pudding that you are here, which encourages us to do more and more in the future and bring to you more interesting and up-to-date topics for information and knowledge. Last but not the least, I would like to thank Ontario Science Centre for providing us this venue year after year to let us host this event. The session is officially adjourned. All of you are requested to go upstairs in the exhibit hall where you can meet and greet the speakers. You can have more questions and any other which you may like to speak to them in person over some refreshment. Thank you once again, and drive home safe. Good night.